Hello everyone, welcome to our weekly series of CBSE class 10 and today we are continuing with our chapter 3 pair of linear equation in two variables. As part of the series we have already completed part 1 and part 2 in which we have already covered the basics of linear equation in two variables and the geometric and graphical analysis of pair of linear equations in two variables. In part 3, we are going to continue with the algebraic method of solving the pair of linear equations. So let's learn. So the algebraic method of solving a pair of linear equation in two variables, we have two basic methods. The first method is called as the substitution method. We have been given two pair of linear equations and we will learn how to solve this pair using the substitution method. As the name suggests, here we are going to substitute. So let us understand what. So the given equations are x minus 2y is minus 4 and 2x plus 3y is equal to 13. This is my first equation. This is my second equation. Now from one of the equations, whichever we find comfortable, we will try to write the value of one variable in terms of other. So for example here, in equation 1, what do I see? I can write x as minus 4 plus 2y. Now this value of x I substitute in the other equation. That means we will substitute in place of x in the second equation as minus 4 plus 2y plus 3y is equal to 13. If I solve it further, when I open bracket, I get minus 8 plus 4y plus 3y is equal to 13. Therefore, 7y is equal to 13 plus 8. Therefore, 7y is 21 and y becomes 21 by 7 which is 3. So this method wherein we write one variable in terms of another variable from one equation and the value of obtained variable we substitute in the other equation. This method is your substitution method. Now here we have only found the value of y. How we will find the value of x? Now in either of three equations we can substitute the value of y to get x. The simplest method is I substitute it in equation 3. Put y is equal to 3 in equation 3. We get x is equal to minus 4 plus 2 times 3. Minus 4 plus 6 which is x is equal to 2. So therefore the solution is x is equal to 2 and y is equal to 3. Always a very good practice. Substitute the values of x and y in your equations and verify. So if I want to verify in the first equation 2 minus 2 times 3. What am I getting? 2 minus 6 which is minus 4 which is equal to the right hand side. Second equation also if I verify 2 times 2 plus 3 times 3. This is equal to 4 plus 9 which is 13 which is my right hand side. Therefore, the value of x is equal to 2 and y is equal to 3 is the solution for the given pair of equations. And this method is your substitution method. Let us take one more example. Again, solve using substitution method. My equations are 7x minus 2y is 11. This is my first equation. 3x minus 11y is 25. This becomes the second equation. Now, again, from 1, I can write 7x is equal to 11 plus 2y. X becomes 11 plus 2y upon 7. This becomes the value of x. Now, since I have obtained the value of x from the first equation, I'll substitute this value in the second equation. So, put x in equation number 2. 3 times in place of x, I will write 11 plus 2y whole upon 7 minus 11y is 25. We get 33 plus 6y over 7 minus 11y is equal to 25. The denominator is y. The denominator is 1. We take LCM. We get 33 plus 6y. If I'll multiply 7 here, I will get minus 77y is 25. Let us further solve. We get 33 minus 71y is equal to 175. Minus 71y is equal to 175 minus 33. We get 142. Y is equal to 142 over minus 71. On cancelling, we get minus 2. So the y is equal to minus 2. Now put y is equal to minus 2 in equation 3. What do I get? X is equal to 11 plus 2 times minus 2 by 7. 11 minus 4 by 7, 7 by 7. So we get x is equal to 1. So the solution is x is equal to 1 and y is equal to minus 2. Let us verify. In the first equation, put x is equal to 1 and y is equal to minus 2. 7 plus 4, 11. First equation verified. Second, in place of x 1, in place of y minus 2. 3 plus 22, which is 25. So the second equation also verified. Therefore, the solution is x is equal to 1 and y is equal to minus 2. I hope this method of substitution is clearly understood. Now, let us see one word problem and try to solve this word problem using the substitution method only. Let us read the question. The ratio of incomes of two persons is 9:7 and the ratio of their expenditure is 4:3. If each of them manages to save rupees 2000 per month, find their monthly incomes. In the question, since ratio of incomes is given 9:7, so let income of first person be 9x and income of second person be 7x. Also, ratio of expenditure is given 4:3. Therefore, we can assume let expenditure of first person be 4y and expenditure of second person be 3y. Also given the saving is 2000 per month for each. Now we know income minus expenditure is your saving. Therefore, for first person we get income 9x, expenditure 4y. So 9x minus 4y is 2000. This becomes the first equation. Similarly, for second person we get income 7x, expenditure 3y. So 7x minus 3y is 2000. So this becomes my equation 1 and equation 2. Now let us try to solve. We will be using the substitution method to solve this. So from the equation 1 I get 9x is equal to 2000 plus 4y. Therefore x becomes 2000 plus 4y upon 9. This value of x, since I have obtained from 1, I will substitute it in second equation. Put x in second equation. We get in place of x I will write 2000 plus 4y by 9 minus 3y is 2000. Let's open the bracket. 14,000 plus 7 times 4 is 28. Here I am taking the LCM also. Upon 9 is 2000. This 9 will get cross multiplied. So 14,000 plus y is 18,000. Therefore y becomes 18,000 minus 14,000, which is 4,000. Put this value of y in equation 3. We get x is equal to 2000 plus 4 times 4000 divided by 9. We will get 2000 plus 16,000, which is 18,000, divided by 9 is 2000. Therefore, income of first person becomes 9 times 2000, which is 18,000, and income of second person becomes 7 times 2000, which is 14,000. I hope you have understood this question and also the method of substitution to solve the pair of linear equations in two variables. Now let us move forward and learn the next method, which is the elimination method. The word elimination comes from the word eliminate, remove. So here we will try to remove one of the variables from the equations so that we can convert both equations in one variable, which then becomes easier to solve. So let us see how we have to do this. In this case, we are having two equations. X minus 2y is minus 4 and 2x plus 3y is 30. Now if you see, if somehow we make the coefficients of x or y same. Let us see by making the coefficient of x same first. Now how can we make the coefficient of x same? So here the coefficient of x is 1, here it is 2. So we start by multiplying the first equation by 2. Now when I say I have to multiply the equation by 2, that means all the terms from left hand side to right hand side all will get multiplied by 2. What do we get? 2x minus 4y is equal to minus 8. And the second equation will be 2x plus 3y is 13. As it is, we have not changed the second equation. Now since I am having two equations in which the coefficients of x are same, so what we can do? Subtracting 4 from 3. Now when I say subtract equations, what we are trying to do? We'll subtract all the terms from the left hand side and all the terms from the right hand side together. How we will do it? 2x plus 3y minus 2x minus 4y is equal to 13 minus minus 8. I hope this is understood. Now when I open the bracket, what do I get? I get the 2x terms eliminated. This is exactly what we are trying to do when we are trying to eliminate. Here 3y plus 4y becomes 7y, which is 21, and on solving further I get y is equal to 3. Now this value of y we can put in either the first equation, the second equation, the third equation. So put y is equal to 3 in, let's say, equation number 1. We get x minus 2 times 3 is minus 4, x minus 6 is minus 4. Therefore, we get x is equal to minus 4 plus 6, which is 2. So, x is equal to 2 and y is equal to 3 becomes our required solution. We can also verify to cross check our answer. Let us verify. If I put in first equation x as 2 and y as 3, I get 2 minus 6, which is minus 4. My right hand side is obtained. When I'm trying to verify my second equation, again in place of x I put 2, in place of y I put 3. 2 2s are 4 plus 9, which is 13. I get my second equation. Now just one small introduction to a method which can reduce the steps of calculation here. How can that be done? When I write my equation like this, I can directly do subtraction by changing the sign of the terms which are in the second equation. For example, I know I have to subtract these two. 2x is positive, I will make it negative. 3y is positive, I'll make it negative. 13 is positive, I'll make it negative. And I can directly do the subtraction without writing the steps. Here 2x minus 2x will become 0. Minus 4y minus 3y will become minus 7y. Minus 8 minus 13 will become minus 21. And we can also get y as minus 21 by minus 7 as 3. This method, if practiced, can reduce few of your steps. If you are comfortable, you can do this method also. Otherwise, this method can always be used. Now, let us see one more question based on the elimination method. I have used the similar questions so that you can easily compare which method you are more comfortable with. Here we are having equations as 7x minus 2y is 11 and 3x minus 11y is 25. Now again in this question we can either make the coefficients of x same or y same. Now let us try to make the coefficients of y same. Now in first equation the coefficient of y is negative 2. In second equation the coefficient of y is negative 11. So generally how can we make it same? Either by multiplying both the equations with the opposite coefficients. What exactly I'm trying to say is I will start by multiplying equation 1 with 11 and equation 2 with 2. What I will get? When I multiply the first equation with 11 and the second equation with 2, we get 77x minus 22y is 121. 6x minus 22y is equal to 50. Now again, since the signs of both the y coefficient are same in equation 3 and 4, we always subtract. And how do we subtract? We subtract by changing the sign of the terms which are written in the lower expression. Here 6x is positive, I'll make it negative. 22y is negative, I'll make it positive. 50 is positive, I'll make it negative. Let us solve this. So 77x minus 6x is 71x. This will get cancelled. This is equal to 71. Therefore, value of x is 1. Now put x is equal to 1 in any of the equation. Let us put it in equation number 2. What do we get? We get 3 times 1 minus 11y is 25. Minus 11y is 25 minus 3, which is 22. Y is equal to 22 over minus 11, which is negative 2. So the solution becomes x is y and y as minus 2. And if I verify 7 times 1 minus 2 times minus 2, 7 plus 4, which is 11, and 3 times 1 minus 11 times minus 2 is 3 plus 22, which is 25. Hence verified. This method is elimination method. Now let us see one more word problem based on elimination method. The question here says the sum of the digits of a two-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. Now, before we start attempting to solve this question, let us understand one small concept. Whenever we look at a number, for example, I'm having a three-digit number which is 347. Now, this together is a number and it is made up of three digits 3, 4 and 7. Correct? Now, if I ask you to write this number using the digits in the expanded form, how we will write it? We will write 347 as 3 times the place value of the 3 plus 4 times the place value of 4 plus 7 times the place value of 1. So whenever a number has to be represented using the digits, we represent it using the place value and the face value of the number. Now let us translate what we have just learned right now. Here the question is saying The sum of the digits of a two-digit number is 9. Here they are saying that you are having a two-digit number and the sum of the digits of the two-digit number is 9. Since we have to find the number, we'll start by assuming let the digit at ones place be x and the digit at tens place is y. Now here I have only got the digits. The digits at ones place is x, the digit at tens place is y. Now if only digits are known, how can I frame number out of it? Using my place value for individual digit. Therefore, my original number becomes 10y plus x. This becomes my original number. What information we are given? That the sum of two-digit number is 9. Given to us is the sum of x plus y is 9. This is the first equation given to me. I found my digits and I found my original number. What additionally is given? Also, 9 times this number is twice the number obtained by reversing the order of the digits. Now, the same number, if I reverse the order of the digits, the same number will become xy. But again, x and y are just the digits. So, what will be the number? On reversing, I will get the new number is 10x plus y. The relation given in the second statement is between the original number and the new number. Let us read the condition again. As per question, they are saying 9 times this number. This number is the original number. So 9 times the original number is, that is equal to twice 2 times the number obtained by reversing the order of the digits. So which number is obtained by reversing the order? It is 10x plus y. Let us simplify this. We will get 90y plus 9x is equal to 20x plus 2y. On further solving, we get 90y minus 2y is equal to 20x minus 9x. 90y minus 2y will become 88y. 20x minus 9x will become 11x. So, the equation becomes 11x minus 88y is equal to 0. I can take out my 11 common. So, I get x minus 8y is equal to 0. So, the second equation becomes x minus 8y is equal to 0. This becomes the second equation. Let me write down the equations again. So this is the first equation and this is the second equation. Now again here, since we are trying to do this equation by elimination method, here I can see both the x are positive and their coefficient are same. So again we will subtract. So this is x positive. I'll change the sign to negative. This is negative. This will become positive. The sign of 0 is immaterial. We get x minus x is 0. Y plus 8y becomes 9y is equal to y. Therefore, y is equal to 1. Therefore, the digit at the tens place is 1. X plus 1 is equal to 9. We get x is equal to 8. For the original number, digit at ones place is 8 and the digit at tens place is 1. Therefore, the original number becomes 18. I hope this question is also understood and the method of solving is also understood. Thanks for watching part 3. The discussion of this chapter, pair of linear equation in two variables, is being divided in 5 parts. We have completed part 1, part 2 and part 3 so far, and using all these concepts, we can easily solve the questions from the exercises 3.1, 3.2 and 3.3. In the next part, that is part 4, we will solve some more additional practice questions from the same chapter, so stay tuned. Thanks for watching. Do like the video, share it with your friends of class 10th, and please ring the bell icon to get the notifications as and when a new video is posted. Enjoy learning.